Hi folks, I'm Prof. Joe. I'm a professor for automation and measurement technology at the University of Applied Sciences in Kempten in the very south of Bavaria. And today we are some more talking about an introduction to measurement technology, the AI-accompanied lecture series I'm giving right now on YouTube and at my university. So just feel free to use the AI link below to that GPT. That helps you to learn the contents of this lecture. And I'm only here to get you some more additional stuff, some core concepts, and to answer your questions. So feel free to ask anything down below in the comments. The part one of that introduction was about basically units and some basic stuff, some basic definitions. To repeat those, the basic definitions we are really onto are our measurement quantity, the physical quantity, like the temperature of an object, and on the other side, our measurement value. That star in this series will mark the measurements. That is the thing, the quantity we don't know, we want to know, and we will get some glimpse of what size it has, what quantity it has actually, by using a measurement device, which helps us to get a value for what we want to know. That measurement device, it has a bunch of influences from the outside. Perhaps it has some inside influence, like a battery or something like that, which also influences the measurement. But in the end, what that measurement device does is, it takes our measurement X and gives us some value for that measurement quantity. It takes that measurement quantity we have and gives us some measurement value. Now, the fact that we don't know about the quantity actually doesn't harm us very much, because that function is the interesting part right now for us, because it tells us how that value we get correlates to the quantity, how we can look at the quantity using the value. So, drawing some diagram, that means we have some measurement value down there. And now, looking at it backwards, we can just use the inverse of that function to get our quantity, which can have any form basically. Yeah, that's what we call the characteristic function, the characteristic curve of a measurement device, which connects the measurement value to the measurement quantity. That can be arbitrary. That's what I painted right now. But we have some other styles. What we normally want is some straight line for sure. What we often also get are something like exponentials or polynomials or whatever you could imagine. In the end, we don't care about those curves, even if it's given by a set of arbitrary points connected with linear straight lines. The important thing is how they connect each other. And the other thing which is interesting about those curves is how is the sensitivity of our measurement device. And that is given by just looking at the steepness, the slope of our curve. So in the case of a straight line, that's no problem. It just has one slope. In the case of a curve, we can go here and define some sensitivity in a certain point. Interesting, at least, for certain measurements to get into an area of our measurement device, including the sensor and everything, which has an area of a high sensitivity. Sometimes we even want a low sensitivity, but most of the time we want a high sensitivity. So we get a big reaction on the measurement value side for a small change in the measurement quantity size. That leads us to some definition of a sensitivity, which is just the derivation of our characteristic function f to the measurement value or to the measurement quantity. We won't care about that at the point, just we can use that definition to get us some glimpse of how sensitive our device is, meaning we also can have some correlations to get just an idea of how steep we are using some parts of the curve, defining the slope. One important thing which is useful in practical usage is a living 0 point, meaning we have a curve like the black one over here which hits that y-axis above 0. What does that mean? Think of a light barrier. When you cross it, it will give you a value, and now if you define those values which are sent by the light barrier that way, that you always get a value. So you get, when it's not, so when nobody is within the light barrier, it will give you a value, and it will give you a value when somebody is in the light barrier. You ensure that you can recognize if that device, that light barrier is defect. Meaning, when it's not working, it would give you a value of 0, and by that you know it's defect. So that living 0 point is an important thing you can use in all practical senses. It's the, let's say it's the normal way you would define a sensor signal. Sensor signals should be above 0. When a 0 signal has an important, gives you important information about your measurement, that's not good. Because when the sensor is defect, it would give you some important information, which actually has to be wrong, because the device, the sensor is defect. Having talked about that curve, that function, it's a static function, and in reality, our measurement device isn't that static at all. Meaning, looking at the time response for our measurement value. Imagine there is some measurement quantity at that point hitting our device. We will see that we'll get a response which looks like that. So there's a dynamic part our measurement device brings along. We, looking at the basics of measurement technology, won't look at in very detail. We will only talk about the static stuff behind here. That stuff which can be represented within that characteristic curve I was talking about. That's important to know, because what does that mean for your practical issues? That means wait. Just wait. Wait until your values are steady. And moreover, a very important other point. Today you won't do a measurement on your own. You will program some devices to do your measurements. So, for the program, that means program waiting times, which are appropriate for your measurement. The important thing is to look at that stuff, to think about that stuff, and not just to use your device given to you. Kind of using an Arduino, measuring the temperature right away of some time-critical process can be critical itself, because you don't know about the time criticality of the Arduino whatsoever. You have to think about it. That's the important point. You have to think about it, meaning you have to wait in the end to get your static value, your static measurements. So, finishing the introduction, normally there's some outlook and some outcome. Talking about that, as just some simple things I want to tell you. Measurement technology sounds not like awesome shit. It's in the word, it's boring somehow. But on the other side, thinking about a world we are living in right now, measurement technology is hell of important. Why? Just look at your cell phones. They are packed with sensors, with measuring devices. All of those devices have to cope with all that stuff. Units, errors, and whatsoever. Look at your car. It recognizes that the door is opened and closed. That is about measurement technology. And it's something we expect nowadays. We expect our car to know if the door is open or closed. We expect that from the things around us. And as we expect it from the things around us, they have to have sensors. Why do we expect that? Because the humankind is a specialist in measuring things. Just think of your skin. On every which place on your body you can feel something, you can feel pressure, you can measure pressure actually. You can feel temperature, you can measure the temperature. We can see crazy good compared to some other species or other devices out there. We can speak, we can hear. We can have a glimpse of the humidity around us via our skin. Those are crazy advanced measurement technologies. You know, it's a body covering measuring device, our skin. That's fascinating, asking me. And that's the reason why we want our cell phone to feel the same as we do. We expect our cell phone to feel the same way that we do. And that's the reason why we use those new devices and we like to use them, because they feel as if they are somehow human. And that gives us some social interaction possibility. So in the end, measurement technologies grab deep into every part of life nowadays. If you like that stuff, feel free to subscribe. And if you like the content, feel free to watch any following video which will come up, and any video asking and answering your questions. And feel free to ask those questions down below in the